Welcome to The Explainer. Today, we're literally stepping outside the four walls of the traditional classroom. We're going to uncover the absolutely fascinating science of how students learn through exploration. You know, it's wild how just a simple shift in environment can completely transform how we absorb, process, and actually retain information about the natural world.
To set the stage for our journey, I want to share this beautiful Sanskrit verse from our source text. It says, "Trees stand in the sun and give shade to others. Their fruits are also for others. Likewise, good people bear all hardships and bring welfare to others." Just a wonderful reflection, right? Starting a lesson with this kind of deep appreciation perfectly primes a student's mindset. It completely shifts them from just, passively receiving facts to an active state of reverence and curiosity about the living world they're about to step into.
So, that leads us right to our big, guiding question for today's explainer. How do we turn a simple walk in the park into a literal masterclass in scientific observation? Because, make no mistake, we aren't just talking about a casual, fun little outing here. No, we're looking at a highly structured methodology of learning that's cleverly disguised as an adventure. Okay, let's dive into this roadmap. First up, the nature walk begins. Then we'll look at engaging all the senses, recording what we see, grouping plants and animals, and finally, appreciating our local biodiversity.
All right, let's kick things off with Phase 1. The nature walk begins.
Now this is the crucial first step where the learning arc moves away from the theoretical classroom and straight into the vibrant field of nature. And what really makes this work is the diverse mentorship. The students aren't just led by their regular teacher. They're guided by Dr. Raghu, who's a formal scientist from a nearby lab, and Maniram Chacha, a highly respected elder from the local community. This dynamic is honestly incredible. You've got Dr. Raghu bringing in those formal scientific objectives, setting the goal to experience nature's variety. And at the exact same time, Maniram Chacha brings this deep, traditional community wisdom. He's an expert at mimicking bird calls, identifying local flora and fauna, the whole shebang. Combining these two perspectives, it absolutely fuels the students' curiosity right out of the gate.
Once they're out in the field, we shift into Phase 2, engaging all the senses.
This right here is where students start developing their foundational cognitive and sensory skills. The key takeaway? Learning doesn't start with textbooks, it starts with raw, immersive sensory input. Dr. Raghu actually tells the kids to actively notice the huge variety of smells in the park, while Maniram Chacha urges them to really carefully listen to all the different sounds. They aren't just looking around, they're actively soaking in multisensory data. And when Maniram Chacha starts mimicking the unique calls of different birds, the students just naturally, enthusiastically start copying him. That physical act, actually mimicking the bird calls, it instantly takes the abstract concept of natural diversity and grounds it into a lived, unforgettable experience. And doing this brilliantly highlights the sheer visual diversity students start to notice once their senses are fully dialed in. Think about the stark contrast between, say, a hibiscus and common grass. On one hand, you have the vibrant, complex structure and really hard stems of the hibiscus flower. On the other, you've got the delicate, soft, super thin blades of everyday grass. They're literally learning to spot these extreme variations in nature with their own eyes. But of course, observation is just the starting line. That brings us to Phase 3, recording what we see. This is the exact moment the students level up from being passive observers to active scientific data collectors. Armed with their trusty notebooks, they start structuring all those raw observations into categorized field data. They aren't just jotting down, "Hey, I saw a plant." No, they're breaking down the local names like common grass or tulsi and actually categorizing their specific features. They're writing down that grass has a soft, thin stem with alternating leaves, while tulsi has a hard, thin stem but its leaves are arranged in opposite directions. What we are seeing here is the core of scientific taxonomy happening in real time.
And they take that exact same structured approach and apply it to animals, too. This forces the kids to look way beyond just the physical appearance of the creatures they stumble across. Now they have to analyze behaviors, habitats, diets, the works. They note that a crow lives in a tree, eats insects, and can both fly and walk. But an ant lives in a soil nest, eats seeds, and gets around on 6 legs. They're not just making a list, they're literally mapping out an entire ecosystem right there in their notebooks.
To really lock that data collection in, the students get hands-on with synthesis. They put together a scrapbook using fallen leaves, flowers, maybe even feathers they find scattered on the ground. And they're always super careful not to pluck or disturb anything living, which is a great lesson in itself. But turning these physical, found artifacts into a scrapbook, it's incredibly powerful. It literally solidifies a fleeting memory of a walk in the park into structured, tangible knowledge. They can actually hold their learning in their hands.
Once all that amazing data is collected, we enter phase 4, grouping plants and animals.
Let's move to and see how this builds, because this is where all that raw field data is used to find larger patterns and carve out broader scientific categories. Back inside the classroom, the students break into groups and use cards detailing all the plant and animal features they just observed. First, they pull the cards. Then, they observe the various listed features. Next, they group them based on commonalities. And finally, they discuss the varying bases of these groups with the entire class. This step-by-step sorting activity, it is an absolute masterclass in teaching critical thinking and logical categorization.
And during this whole discussion, something genuinely fascinating happens. Different students end up choosing completely different common features for their groupings. One group might look at a particular flowering plant and lump it with others purely based on its height, but another group, they might categorize that exact same plant based entirely on a presence or absence of those distinct flowers. This is huge. It teaches the students that scientific classification can actually have different, totally valid parameters depending entirely on the specific question you're trying to answer.
Now, to answer even deeper questions about categorization, the exploration pushes even further. The kids head to an open area to carefully dig out wild herbs and grasses using a kerpie, which is a small trowel. Getting their hands dirty to physically expose and compare hidden root structures, that adds a completely new, totally thrilling layer of scientific investigation to their grouping exercise. They quickly realize that some of the most essential features for understanding nature are actually hidden right beneath the surface.
And that profound realization brings us to our fifth and final phase, appreciating our local biodiversity.
Now, what's really interesting about this synthesis phase is how all those individual observations, the data tables, the sorted cards, they all suddenly snowball into a massive, big-picture understanding. Thinking about this collaborative Blackboard exercise totally captures the magic of learning together. After closing their eyes and reflecting on their absolute favorite plant or animal they saw, the students all head to the blackboard and draw them together. This isn't just some arts and crafts project, guys. Seeing dozens of different plants and animals filling up the board vividly proves to the entire class just how vast, rich, and alive their local ecosystem truly is. It visually locks in the learning for every single student.
And that beautifully anchors